Hello, algebra students. Mr. Lawrence here, and this is your video for the weekend of May 3rd, 4th, and 5th. And we're going to learn how to multiply and divide rational expressions. I personally think this is easier than adding and subtracting. I'm just going to look to factor and simplify, factor and simplify. And remember, when I simplify a fraction, I have to check fractions this way, and also diagonally. Okay, so let's get right down to it. Now, I'm thinking, what are the factors of the numerator? Well, I've got an x and I've got a 1, right? In the denominator, I have a 1 more than x and then an x. Well, it seems to me that these x's will cancel each other out. Nothing else is going to cancel, so this is going to simplify to 1 over 1 more than x. All right, now I do have to mention my restrictions, the number that x cannot equal, and I know right here that x can definitely not equal -1. But I also know right here that before I cancel it, x cannot be 0. I need to find my restrictions before I actually cancel things out. Okay, that was a real simple one. Let's look at one a little bit more challenging. This one is going to need to be factored. Okay, so the first thing I'm going to do is factor. So I'm going to factor this numerator, and it looks like I'm going to GCF it. I'm going to pull out an x, and I'll have x times the quantity of x plus 2 over x plus 3. And I'm going to pause because the bell just rang. Okay, so I'm going to have to finish factoring this other fraction here. And obviously, there's nothing to factor in the numerator. The denominator is the difference of perfect squares, and it's going to factor as x plus 2 times the quantity of x minus 2. So now, I'm going to check all 4 ways. First of all, I'll check vertically this way. I don't see anything that's going to factor. Some of you might be thinking this x, and I'll say no, because this is 3 more than x. This x and this 3 are connected by addition. Division, or simplifying a fraction, cannot undo addition. All right, so I can't simplify anything vertically here, so I check that direction. I'll come over here and check the other vertical direction. Again, I don't see anything that's going to simplify. Now I'm going to look diagonally down, up from the left down to the right, like that. Okay, and I notice that one of my factors is an x plus 2. In the denominator over here, I have another x plus 2. Those can cancel out. I don't see anything else that'll cancel out, so I'm going to check this way, diagonally up from the left, up to the right, I should say, down at the left, up to the right. And I don't see anything that'll factor there. Okay, well, I'm going to do x times x and get x squared. And in the denominator, I'm not actually going to FOIL. I'm going to leave it in factored form because it'll be easier for the reader to tell that nothing else will simplify. And there's my answer. Now, of course, I do have to state my restrictions. And remember, I want my restrictions before I cancel things out. This is only true when x does not equal -3, +2. And I also have to check this one here, which would be a -2. So this problem actually has 3 restrictions. I can say that this black equation equals this answer, x squared over x plus 3 as a quantity times the quantity of x minus 2. And that's true when x does not equal -3, 2, or -2. So that's what we're saying. That when I multiply these, I get this purple one when x is not those numbers. If x is any of those numbers, I can't say it's true because then something becomes undefined and I can't do an operation on a number that's undefined. All right, number 3, look in the factor again. So I'm going to factor this numerator here, the x squared plus 5x plus 6, and that's going to factor as x plus 2 as a quantity and x plus 3 as a quantity. The denominator, perfect square trinomial, it's going to factor like x plus 3 as a quantity times x plus 3. The numerator of the next fraction will be x plus 3 times x minus 3. The denominator of the next fraction, perfect square trinomial, it's going to be x plus 2 as a quantity and another x plus 2. A lot is going to cancel out. If you want to go find restrictions right now, you certainly can. You can say, well, you know, x cannot equal -3 or -2. Okay, and then you can cancel. All right, going to look vertically. It looks like I have an x plus 3 and an x plus 3. They're gone. Vertically in a second fraction, I don't see anything that'll cancel. Diagonally, down to the right. So I have an x plus 2 and an x plus 2. What's left in this numerator? It's a 1 because I'm dividing. I'm not subtracting. I don't get a 0 there. All right. Now I'll look up to the right, and I see an x plus 3 and an x plus 3. There's a 1 left there. So now my problem is really 1 times x minus 3, which is simply x minus 3. My denominator is 1 times x plus 2. And there's my solution right there. I'm not solving for x. I'm just telling you what this multiplication problem simplifies into and the restrictions on x. Okay, let's check out problem number 4. I'm going to have to factor, and I believe the numerator is going to factor like this. Okay, the denominator is going to factor like this, but I have to change this problem to multiplication, right? When you divide by a fraction, you multiply by its reciprocal. Remember that, 5 divided by a half is 10, right? So we'll have to do 5 times 2. So I changed the multiplication and flip, and we've already explained why that's true a long time ago. You guys were pretty good with that. Oops, I don't want to write there. Let me get rid of that. Go away, please. Thank you. All right, so let's go back here to problem number 4. So I'm going to flip this fraction, and I'm going to factor this, but it's going to go in the denominator, x plus 3 and x minus 3. And then I'm going to factor this, and it'll be in the numerator now because I used the reciprocal, x plus 2 and x plus 4. Now, I can do my restrictions again if I want. So I know that x cannot equal, looks like plus or minus 3, plus or minus 4. And I also have to check this numerator for a restriction because it used to be in the denominator, and I'm going to pick up a negative 2 right there. If any one of those quantities turns to 0, this problem can't be simplified. All right, so now I'm ready to cancel. And let's see here. Vertically on the left, I got an x minus 4 and an x minus 4. Vertically on the right, I don't see anything to cancel. Looking down to the left, or down to the right, excuse me, I see an x minus 3 and an x minus 3. Looking up to the right, I see an x plus 4 and an x plus 4. And so my new problem is going to be x plus 2 over x plus 3 when x does not equal those numbers. And there's my answer. Same exact thing for division, but I have to remember to flip and multiply. All right, so I got a division sign, so I'm going to flip and multiply. I'm going to factor, first of all, my numerator in the first fraction. I'm going to get x, and I think that's going to be a minus 9 and an x plus 2. The denominator is going to be an x plus 2 and an x plus 5. Change to multiplication. I'm going to factor this, but it'll go in the numerator, and that will be an x plus 5 and an x minus 5. And then here I'm going to factor, and I'm going to pull out a GCF and get an x plus 2, but it's in the denominator because I flipped my fraction. All right, I'm going to go ahead and find my restrictions right now while I'm thinking about it. X cannot equal negative 2, negative 5. X cannot be 0. This one's going to tell me negative 2, but I already have it. I'm going to look in the numerator because remember, this used to be the denominator of the original problem. Negative 5 there, I already have it written down. That will be a positive 5. So x cannot be any of those 4 numbers. Now I'm ready to cancel. All right, looking vertically, looks like I have an x plus 2 and an x plus 2. Vertically here, I don't see anything that'll cancel. Down to the right, I don't see anything. Up to the right, I see an x plus 5 with an x plus 5. This problem is going to become x minus 9 times x minus 5 over x times the quantity of x plus 2. And that's true when x does not equal those numbers. And there you go. Now, I could FOIL that out if I want to and distribute that X, but that would make the problem look more complicated. And I want the reader to understand that everything that is canceled out has canceled out. So that's the problem right there. All right, that's the lesson. We'll get some practice with this Monday in class. Mr. Lawrence signing off. Good night, everybody.